Lars,
Yes.
is it okay just to say hello to Donna while we're waiting?
Yes, we're just waiting a moment.
Okay.
Go ahead. This is Ellen Shaw-Smith. This is Donna Jackson Nakazawa.
Hi, Donna.
Nice to meet you.
Thank you. I'm a neurofeedback provider in Hadley, Massachusetts. And I work a lot with trauma and other conditions because things, people have a variety of conditions. And we're just so happy that you're here today.
Well, it's a pleasure to do this and to do the 3-part series is coming up. Yeah, I'm really delighted to do it. So Hadley, Massachusetts, that means you're not far from one of my favorite people in the world.
And I know exactly who you're talking about because
she's
mine also. We're all blessed. We get to live in this little mecca here. So
yeah, absolutely. Super, super charged area of the world academically and in terms of great thought leaders. The only downside you have up there is the snow.
And we had horrible winds last night and lost power in my town, but otherwise it's pretty good here. So
it's pretty awesome there. Yeah, we've been having a lot of northeastern weather here in Maryland as well.
Well, thank you so much for sharing your wisdom with us.
Pleasure, pleasure, pleasure.
Donna, I want to congratulate you on the Brain Futures publication.
Oh,
I'm so thrilled about that. I'm Hogan Pessinello. I'm in Maryland. I know Mark Trollinger. I've tried to help with the CPT coding when I can.
What an ordeal, right? Well, happy Tuesday, fellow Marylander. And yeah, Brain Futures is an amazing organization. I'm very happy to be on their advisory board and help them where I can. And Mark is such a leader in bringing neurofeedback into the everyman domain, and also just an enormously gifted practitioner.
So what if we get started?
Okay, let's do it. And I just want to say, I'm happy you're all here. This is very informal here today. And we're just chatting. My actual 3-part prepared, diligently prepared, peer-reviewed research delivery in the 3-part series will be accompanied by, well, I'm a stickler, lots of slides. and more details about the science. So this is sort of a pre-chat, and I'm really looking forward to it because it's going to be open and casual, and I'm glad you're all here.
Thank you. So welcome everyone to Eager and EEG Learn's second live stream. And today we're going to talk with Donna Jackson Nakazawa, who is an author and speaker. And we're going to talk about the immune system and the brain and inflammation and the work that she has done, years and years of research in this area. I'm gonna say a little short bio just to kind of contextualize the conversation today, and then start off with a few questions about the work that she's done recently. And in particular, we're interested in brain health and trauma in the time of COVID. And so we'll ask some questions about that, and then with a bit of luck, we'll have lots of time for you all to ask questions as well. As you may notice, this is being, we have an ASL interpreter working with us today because accessibility is super important to all of us who are organizing these events. So I look forward to your insight and your feedback and your questions and concerns about any of these kinds of things. So let me start with talking a little bit about Donna Jackson Nakazawa. Donna Jackson Nakazawa is an award-winning journalist, internationally recognized speaker. Her work explores the intersection of neuroscience, immunology, and human emotion. Her mission is to translate emerging science in ways that help those with chronic conditions find healing. She's author of 6 books, including the newest, The Angel and the Assassin, the tiny brain cell that changed the course of medicine. It illuminates groundbreaking discoveries, recent discoveries that elucidate the biological link between our physical and mental health. Other books that are well known are Childhood Disrupted, How Your Biography Becomes Your Biology, and How You Can Heal, The Last Best Cure, and Does Anybody Else Look Like Me? Actually, there's a few more. There's a bunch of them. She's been published in Wired, Boston Globe, Stat, The Washington Post, Health Affairs, Eon, etc. And in addition to her work as a science journalist, she's also been a speaker in numerous platforms, including the Today Show, National Public Radio, NBC News, ABC News, etc. And finally, she's founder of the recently out Creating Your Healing Narrative, which is Writing to Heal and Neural Re-Narrating program. In this workshop, drawing on her 30 years as a journalist, eliciting interviewees' most deeply felt emotions and insights, coupled with science-based expressive writing and mindfulness techniques, Donna teaches participants the process of neural re-narrating. And hopefully we'll get a chance to talk a little bit about that today. So welcome, Donna. Thank you for joining us today.
Such a pleasure to be here, and welcome to all of you. I'm looking forward to our conversation.
Great. So how did you become interested in the brain, mental health, and inflammation and the mind-body connection? There's a mouthful, but what got you started on this path?
Well, the path really started, so I'm finishing my 7th book now for Random House, which is also about the brain. We can talk about that a little bit later. But I found myself in my early 40s suffering from a severe neurological autoimmune disease, some of the effects of which are still with me today, not visible to you, but very real and present for me. And I was paralyzed on and off, and in Johns Hopkins for long periods of time, sometimes a month. And I spent a lot of time trying to learn to walk again while raising small children. And of course, as a patient, you're thinking about what's happening to you and how to manage your life. But as a science journalist, there was always another part of my brain that was going, well, what is happening inside of me right now, right? Not just what's happening to me and how do I cope with it, but what's actually happening to me on a cellular level. And I come from, this is a personal chat, right? So I'm going to be personal. I come from a long line of journalists. My father's family were journalists and newspaper men at the time. I grew up and cut my teeth in rooms where printing presses were still being done with lead type that the guys would hold in their little canvas aprons, and I'd go in and make little fake newspapers of my own with the blessings of my father. But on my mother's side of the family, long line of very serious scientists, including one who, her father, who was head of cancer research at NIH for 30 years. So we had these kind of two sides of the family, and then a third side on my mother's side, heavy Navy. So there was always this sense of duty and truth and science. And it grew in me in my career as a science journalist that I wanted to be able to present science in a way that would tell stories that would change lives. So it just kind of morphed together with that sense of duty, that sense of service, that sense of wanting to create transformation based on science. And as my own life began to be very affected by autoimmunity and inflammation, I began to look anew at my own family story, in which my father had died when I was quite young, the age of 12. And he had suffered from a number of severe inflammatory disorders, now what we would understand as juvenile arthritis or rheumatoid arthritis. and severe inflammatory bowel diseases. And there was this long line of inflammation and autoimmunity in my family. And as it began to affect me, we also had a series of bone marrow issues and issues with our red blood cells and white blood cells. And this very much impacted my father's sudden death. And as I began to be diagnosed with autoimmune diseases and my bone marrow was doing funky things, I wanted to know all the answers to those questions that I just said. What's going on inside of me on a cellular basis? What do we know? What do we not know? What does it have to do with how I can heal? And what does it have to do with that service-based aspect of why we're here? How can I help others heal? Right? Not just how can I get out of bed and raise my beautiful children, but how can other people get out of bed and live the life that they deserve to have, knowing everything that we know? And then as I was going through that process, I wrote a book called The Autoimmune Epidemic. And then after that, I wrote a book called The Last Best Cure, in which I really dug into psychoneuroimmunology, because I became more and more aware of how our head state and where we are in terms of our mindful awareness begins to affect our levels of inflammation. And then I began to follow all the research on how trauma sets the stage for the brain and the mindset of the brain in ways that very much impact our set point for well-being and our set level for inflammation. And it seemed to me that, the world just split open as I began to follow this science. And really it began over the past 15 years, this watershed time in our understanding that the brain is functioning in constant conversation with our body. But even so, and that trauma sets the stage for what that conversation will be and how it will translate into inflammatory processes and the stress response. So those of you who've read my books know that I've explored that in finite detail in a fine-grained way. And then about 8 years ago, it started this new understanding in neuroscience that the brain itself is part of the immune system, and that little cells in the brain called microglia are actually immune cells that are talking to the immune cells in our body, and that they begin to sculpt the brain in ways based on our lived experience. And that this opened up an entirely new world in terms of our understanding and hope for human healing. And we had missed it. So that is a really long answer. And I'm sorry about that, especially for the translator. But that's the story. And that's how I became interested. And I think I've just been very fortunate in that where I cast my eye and where I wanted to go as a journalist, the science was shifting, Earth was shifting, tectonic plates were shifting. And so I've had the great joy of reporting and talking to all the best minds in the world about our understanding of the mind-body connection on a cellular level, about the brain as an immune organ, about trauma and how it changes the brain and the immune system. And it's just been my great joy to be able to report on it in my books and share it. So there you go.
Thank you. So the piece about the brain and the microglia being part of the immune system, I think that is one of the most arresting things that I've learned recently, because most of us grew up, I would say maybe even all of us grew up thinking that the immune system is this thing that has to do with the body, not that it's happening on a neurological level, on a neurophysiological level in the way that you describe in The Angel and the Assassin. I wonder if you can talk a little bit about why did this get overlooked for so long?
Sure. So we simply didn't know for two basic reasons. One is philosophical and one is anatomical. from a philosophical standpoint, we have Descartes to thank for the idea of mind-body dualism, right? It was 300 years ago. He put forth this idea of mind-body dualism, that the mind and body are functioning completely differently. But not to blame it all on philosophers, early anatomists saw a few things about the human body that made them think that the brain and body weren't really communicating, and that the brain was what we call immune privileged, did not function as an immune system. And the reasons for that were twofold. One is, if you're hammering a picture hook into the wall and you hit your thumb, it's going to get big and red and painful and swollen. Those are the markers of inflammation in the body. But the brain has this hard cover, the skull. And that means that if it were to get inflamed as the body gets inflamed, it would have nowhere to go. Now, of course, in severe trauma, like car accidents, they do have to drill into the skull and relieve pressure on the brain. That said, if the brain were an inflammatory organ, if it could get inflamed, just like your thumb or your knee, it wouldn't make sense for it to have this hard skull. But there's another reason. We have this thing called the blood-brain barrier right at the base of our neck. It's this dense constellation of red blood cells. And these red blood cells, many early scientists tested, kept immune cells from the body from rising up into the brain. So these three things together told scientists, ever since for centuries, gave them the idea that the brain was immune privilege. Microglia were first discovered in the 1920s by the Spanish neuroscientists. And they called them micro because they were the tiniest cell in the brain, and glia because glia are non-neuronal cells, which are thought to be the happy helpers of neurons. Neurons are the glittery darlings of neuroscience, right? They're responsible for our thoughts and feelings and how our brain fires and wires. And we've been talking about them, and I've been writing about neurons for over a decade. But glia were not so flashy or interesting, and microglia in particular were thought to be very boring. They were the housekeeper cells of the brain, the janitor cells of the brain, and they just went and carted away dead neurons, or so we thought. And then about 10 years ago, scientists started to have new tools to be able to look at these cells a little more closely. And then in 2011, two kick-butt female scientists at Harvard, Beth Stevens and her postdoc, Doris Schaefer, began to take a really hard look at these cells. And what they found and spent a year looking at and repeating their experiments until they were sure they could come out to the world and announce it was this. When microglia are activated, just like our immune cells in our bodies, which can become overactivated, they morph from being these good little housekeepers, which actually look like elegant dancers dancing through the brain. And I've seen them in Beth's office. They morph from being these elegant dancers into these big Pac-Man like bushy, hairy cells. If you're old enough for Pac-Man, if you remember what that is. And then they begin to munch away at neural connections and these synaptic neural connections that the brain is trying to make to wire and fire together. And microglia are definitively not really glia. They are immune cells. They were categorized as glia in the 1920s. And that misnomer led scientists to pretty much ignore them. But in fact, on the 7th or 8th day of gestation in the womb, these little microglia cells, they break off from our white blood cells and they rise up into the brain where they begin to oversee our brain health from cradle to grave. We missed that they were up there policing the neighborhood because we didn't think that it was possible for the brain to be an immune organized organ. And yet, all this time, these immune cells have been in the brain policing the neighborhood. So it's very interesting science. And of course, you know, as a journalist, I wanted to reach out and tell the story.
That's wonderful. Thank you. So we're going to talk a little bit about COVID and what your thoughts and research has shown around that. But before we do that, I wanted to ask you about inflammation, because one of the sort of currents and threads running through all of this is the idea that inflammation, it sounds like it's somewhat basic to, is foundational to the whole idea of human, bodily dysfunction and disorder and stuff. Can you talk a little bit about that?
Sure. So the thread that we're keep touching back on, as Lars said, is inflammation. So when I talked about autoimmunity, inflammation is involved. Inflammation is a wonderful thing. It's a miracle. It is our body's way of fighting off disease, including viruses like COVID, or preparing us in states of danger, or getting rid of foreign agents in the body, whether it's bacteria or any kind of environmental toxin. But as we all also know, the immune system is imperfect. It's almost perfect, but it is imperfect. And it can make mistakes. So in autoimmune disease, when our immune system makes antibodies and they go out and they attack something in the body that's foreign, virus, bacteria, parts of foods that our body doesn't recognize, those antibodies are great. They attack that foreign thing and they get rid of it. They take it away. However, the immune system can go too far and create too much inflammation, too much of a chemical reaction, which we can measure in the body by roughly measure with IL-6 levels, C-reactive protein. And we know that when these levels are very high in people, they have what we call systemic inflammation. When that goes to another level, and the body also produces a certain type of antibodies called autoantibodies, auto meaning self, those autoantibodies can begin to attack the body itself. And we have that in over 100 autoimmune diseases, from thyroid disease to celiac to multiple sclerosis to all kinds of different disorders, many of which you know about. So that's the basic on inflammation and autoimmunity. What we also understand over the past 15 years is the study of chronic unpredictable stress and how chronic unpredictable stress works in the same pathways as these other types of environmental stressors that I'm talking about. So we have very good evidence that chronic emotional stress works on the same pathways, signaling immune cells in the body to get revved up in the same way that an environmental hit can do. It's different, but there's a lot of similarity. And with that understanding, we see that chronic emotional stress, or any kind of chronic unpredictable stressor, creates an inflammatory response over time. Now, chronic unpredictable stress is different than acute stress, but when we look at chronic unpredictable stress, we're almost always also looking at the broad category of early childhood adversity, or ACEs, that we look at when we're looking at the effects of trauma on the development and architecture of the brain and the function of the immune system across the lifespan. So what do I mean by that? I mean that chronic unpredictable stress is inflammatory over time, and that in childhood, when kids face chronic unpredictable stressors without adequate support, that creates an inflammatory response. And we know from very good research that that begins to turn on the genes that turn on the stress response in a more elevated way, keeps that stress response on in a more elevated way across a child's development and into adult life. So this is why we can see that kids with ACEs often grow up to have a much higher rate of autoimmune disease and depression. And in fact, an ACE score of 6 or more takes 20 years off the lifespan. So obviously I write a lot about this. So now the pieces begin to come together, right? And now we add in the fact that the brain has its own immune system with these empresses of the brain, microglia, and that the brain is also responding in this 24/7 dance to the world around us, to the environment that we're in. And it begins to answer a lot of really old questions. For instance, why is it that kids who grow up with adversity not only have higher levels of measurable inflammation, which we understand can lead to disease in adulthood? That makes sense, right? Higher inflammation, higher stress response would mean a greater likelihood of inflammatory and other diseases across the lifespan. But how is it changing the brain? And microglia answered this very simple question that no one had been able to answer, which is, how do we begin to see the loss of synapses in brains of children who suffered chronic unpredictable stress, or ACEs? And why do we see this shift in synaptic health and viability in patients who are adults and are suffering from trauma or adversity? What's causing those synapses to literally disappear? And most of you here are, way more knowledgeable about this than I am. But when you look at brain scans and you see these patterns in patients who show distinct patterns for developmental trauma or for depression or anxiety, and et cetera, why were they disappearing? Why do life experiences begin to shift the architecture of the brain in this way? That was a black box of modern science. We knew it was happening. We knew that the relationship was there between heightened inflammation and trauma and shifts in brain scans, but we didn't have the why. And microglia, knowing that they can become these pro-inflammatory cells in the brain, explains to us why we see this connection. So that's how the thread of inflammation plays through all of these different stories of science and into a broader understanding of what creates our human health and well-being from our first earliest stages of life. You're muted. No,
I was muted, yes. Thank you. This, the pieces definitely come together for me around the way that we've thought of these things as separate, the physical health of a person, the mental health of a person, the immune system health of a person. And it sounds like the research that you've done has uncovered that these are all really integrated of a thing, which speaks a lot to what I hear clinicians that join our webinars and meetings talk a lot about, which is the sort of combination of embodiment and mental health, behavioral stuff. And it sounds a little bit, when you're talking about chronic unpredictable stress and ACEs, it makes me think of developmental trauma, which is one that people talk about a lot. We're going to talk about the good news here as well. But I wonder if you could talk a little bit about, so particularly for populations, we know from ACEs, right, that the number of people who have experienced trauma is much greater than we originally thought. Like there was, the numbers are devastating, and maybe you want to talk about that a little bit. But what I'm super interested in is what does it mean for the population that then suddenly confronts a situation like the pandemic, where there is the threat, the actual threat of disease, as well as the lockdown and isolation and all of the attendant mental health and behavioral issues that come with that. What would your explorations in these areas suggest about that?
Well, so we already know, and the research is really growing in this area, our understanding of social isolation and the fear of rejection and fear states in general on the development of the brain and the health of the brain. So for instance, new study came out, I think just 2 days ago, showing that young people cite depression and anxiety as 25% higher in 2 months that they measured, March and July, I think, in 2020 versus March and July 2019. So we know that this effect is real, and we're starting to see a lot of epidemiology on this because, of course, it's been a year that we've all been facing the trauma of the pandemic. So this is a very stressful time, obviously. You know, it's stressful because you can't see the people that you love. If you do go out, you're getting social signals. Your brain is getting signals all the time that you're not safe. You start to cross somebody on the street, you have to cross to the opposite sides. You can't hug your children if they come to see you from school until they take a shower or what have you. There are 1,000 ways in which the brain is getting the message that you're not safe, not to mention the fact that you actually aren't safe because the virus is out there. So across evolutionary time, the brain and the immune system coded isolation as extremely dangerous, because across evolutionary time, if you were isolated from the tribe, it meant that you had been ostracized. And our immune systems very cleverly evolved along with our social interactions to, in fact, rev up in prediction of ostracizing, being left out, or isolation. And why was that? Because across evolutionary time, like if you were in a hunter-gatherer society and you were being laughed at or made fun of, or you didn't get the best food, you didn't have access to the best water, your children didn't have access to the tribe in the same way. And in a worst case scenario, you would be left outside the tribe, where you would be at the open mercy of pathogens, because you would be at the mercy of warring tribes, which would lead to wounding, or you would be at the mercy of predatory animals, which would lead to wounding. So really exciting body of research, and I'm actually reporting on it for the book I'm working on now, called The Social Safety Theory, holds that our brain's biggest job is to tell us if we're safe or not safe. That is its job at essence. Are you safe or are you not safe? It's getting billions of messages every minute telling you whether you're safe or not safe. These messages inform your mind, body, brain, body, immune connection. It leads to your brain and your body cross-chatting all the time. You know, the brain and the body are cross-chatting, your brain's immune system, your body's immune system. Well, what are they talking about? They're really talking about whether or not you are safe. And so now we're living in a time in which we're not really safe. We're also being isolated. We're also facing lots of what the brain might code as rejection. So if you go to the grocery store and you try to pick up a piece of that, you know, pick up the eggplant, but the other person is going and they jump back like you're dangerous, you know they're not rejecting you. But the brain is trying to code everything that's happening to you as whether you're safe or not safe. The messages that you get in the pandemic are that you're not safe socially, you're not safe emotionally, you're not safe physically. And over time, that coupled with isolation can be read as the brain, can be read by the brain and the body as a sense of being left out or rejection. Now, I'm telling you, we know it's not true. You weren't rejected by the world right now, but the brain is trying to figure out if you're safe or not safe. And when it gets a lot of isolation and rejection in your lived experience, our immune systems evolved with our social experiences in ways that led to isolation, upping the immune response in preparation for the worst case scenario to happen. And that is, you're going to be on your own and you're going to be at the mercy of outside environmental influences that could harm you. And your immune system is going to rev up and say, okay, we are ready. And I think that that's why we are seeing such heightened rates right now of depression, anxiety, chronic pain syndromes, physical therapists, psychiatrists, everyone does not have room in their schedule right now for the amount of suffering that they are seeing in their patient population. So that is just a quick primer on what this time is doing to the human mind. And yet I haven't even gotten to the fact that COVID itself, quite obviously, creates a cytokine storm in the body and in the brain. And we have very good evidence now that it activates microglia in the brain, and microglia once again come to the center of the story in terms of seeing that oversculpting of synapses. This is not a new story, by the way. Many early accounts of the 1918 flu, the Spanish flu, show an uptick in psychiatric issues after the pandemic. And of course, we don't know, is it related to the experience of having been sick or the experience of having lived through a pandemic? Or was it a kind of long hauler effect that we were seeing a century ago? We saw huge upticks in psychosis. We also have other good evidence of this. For instance, patients who are hospitalized with severe bacterial infections, which rev up the body's immune system, show a much higher likelihood of later developing depression or bipolar disorder. So we have great evidence of this. The answer to the question, are the brain and body talking to each other, and what are they talking about? Yes, they're talking together all the time, and they're talking about whether or not you're safe. So when you have the added impact of an exterior hit like COVID, which is an infection, and we know that it's also sending signals between the brain and the body, we know that we're going to see some long-term effects on brain health, and we are seeing them. This is also a very interesting disease in that, and terrifying in that, it accesses through the olfactory system, and by so doing, signals the body's immune system, which signal microglia that there is a real problem in the direct domain of the brain. And that's different than a lot of viruses where we think that they don't actually affect the brain directly. The virus isn't attacking the brain directly. We're actually not. I've seen a lot of early evidence that COVID is affecting the brain, and they are seeing COVID in postmortem studies in the cerebellum and several other areas of the brain. But as a journalist, I want to step back and say early days. Super early days. I can't tell you the number of things I've reported on in my career, and we thought we knew 100% what we were talking about. And then 10 years later, we were like, wow, we didn't really understand that at the time. It takes years of epidemiology, and then it takes years of basic science. So epidemiology, you're just looking at cohorts of people, kind of like a vaccine study, and then getting down into actual biology, the kind of work that's done under the microscope in the lab to see whether things are happening in real time. We're a long way from that. We don't know. But if we look historically at what we know about the one pandemic that we have any records of, other infections in the body and how they affect the brain, and we also look at the information we have about how patients with autoimmune disease are more likely to show changes in synaptic health in the brain. We see this in lupus, rheumatoid arthritis, MS, celiac, many other autoimmune disorders. And we couple that with the fact that we have a virus that may actually be found in the brain. I want to say we don't know. There's evidence of it in postmortem studies, but is definitely creating an immune response in the brain that's leading to shifts in synaptic health. Now we've got something we need to be super worried about, and taking care of from the inside in terms of our own health, our own family's health, our own well-being, and then moving out into our smaller community, and then our larger communities, and into our medical communities, And I think we're just so far from doing that yet because we don't really have a grasp of what we're in the middle of right now.
Thank you. Sometimes when I talk to folks about these ideas, the sense that I get from folks is like, if the idea of talking about sort of neurophysiology and medical terminology by itself is not depressing to them, then the actual news that's coming out of it is just, it's a real, it has a real impact on them. But my experience of looking at your work actually is that it's very hopeful. There's there's sort of a thread of the resiliency and the possibilities that runs through that. And I wonder if you can talk, because I know that in the course here, you'll be talking about the practical approaches to how to address the inflammation, all of the physical effects, and also the mental health sort of crisis that's looming as a result of the pandemic. Not to mention the underlying sort of ubiquity of trauma. I wonder if you could talk a little bit about what your sense is, maybe from a general standpoint of just how resilient the human body is, and then in terms of the practical. And we don't really have time, obviously, for you to go into detail about that stuff. But I wonder if you could give people a little bit of a hopeful message.
Absolutely. And so, again, I'm working on my 7th book, and I'm trying to remind people, because it's, sometimes I scare myself with what we know. But at the flip side of all that we know is the promise of epigenetics and neuroplasticity. So everything that I'm talking about is one side of the coin. In my mind, and of course I'm a science journalist and researcher, if we don't understand it, we can't shift. We can't even shift our understanding of what we can do differently, but science can't begin to look at things in a way that can offer new answers. So if you're looking at your human health as something that happens to you, and if you're looking at it as we did 20 years ago, where people were even arguing that there was such a thing as autoimmune disease, can you imagine? That was very much up for debate, that autoimmune disease existed. Now we've gotten through that barrier. If you're up against the idea that the brain is not affected by our environment and that it's separate from what's happening to the body, then you're actually having a conversation that is quite Byzantine compared to the reality of the brain that we have. And that means that the tools you're applying to help people are Byzantine. So science provides this path forward to a new understanding of tools and approaches. And to me, again, remember how I started, long line of journalists and translators and long line of scientists. If we don't have the basic science, we can't shift the way in which we can help out of service to begin to offer the tools of healing. So that's the good news. And all of this means that if the brain is this responsive to the world around it, then we can get in on that. And we can begin to not just talk about the negative influences on brain plasticity, which we've done in some depth here. We can begin to talk about the positive influences on brain plasticity. We are dancing with our environment 24/7. We all know our 5 senses. We really have 6 if you count proprioception. So we can think of the brain as our 7th sense, and it's our most powerful sense. And it is always asking itself, will you, this human organism, be okay? And if that's the case, then the messages that we give the brain through different tools, including neurofeedback, including, I'm a big advocate of writing to heal and neural re-narrating, so many different tools, and we'll talk about that in the course, that we can begin to send different messages to the brain, corrective messages, new messages, rebooting messages. And we can begin to upgrade the brain so that it responds to the world in a way that brings down this heightened stress threat response. And when we can begin to do that, we actually see levels of inflammation decrease. We can see IL-6 go down. We can see C-reactive protein go down. We're actually at a point where we're very close to being able to measure microglial activation in the brain. We can do it with concussion patients, post-concussion. But 5 years from now, we'll be able to measure that activity, kind of like a white blood cell count. We'll be able to tell you what's happening in the body. And yet it all drives to this bigger question of how do we begin to create a world with the tools we need to send the human brain the message that we will be okay? And how do we begin to send these little immune cells in the brain the message, it's okay, you can calm down now, or reboot them so that they go from being these dangerous little assassins to the role that nature intended, which is to be these good angels of the brain. The brain wants to be organized. It wants to do the good things that it does. It doesn't want to be disorganized. It doesn't want to be in a state. Well, I don't mean to anthropomorphize the brain. I'm actually but the brain doesn't enjoy repeating the state of overactive, excitation of the microglial cells. It wants to be in an organized state. And so there's so many tools, neurofeedback, certainly at the top of the list, coupled with the research that we're seeing on gamma light flicker therapy going on at MIT and Harvard, and TMS in patients for whom it's appropriate, and all kinds of other interventions, even writing to heal programs. We can begin to see this shift in inflammation. And I've named 4 out of 20. So that's the promise of epigenetics. We can shift genes in negative ways so that they up the stress response and up the microglial response, but we can also shift genes in positive ways. And how do we do that? We shift the messages that we're choosing in our options toolbar to utilize to send the brain different messages.
I love that. I love the importance of attention, intention, awareness, all of that stuff, and how that really plays a role in health.
And I think we're just at the beginning of this most exciting time. And I guess if there were to be a silver lining of this COVID time, and I'm not sure there is one, especially after a year for most of us, but if they're small ones we all find in our own lives, like who knew that cooking with my children over Zoom could be so fun, but live and learn, or Saturday night family game night, hey, it's great. But it doesn't replace not being able to see or hug my son who's out at Berkeley and can't fly home. So, but if there is a silver lining here, it's really that I think that COVID and our understanding of the role that isolation and the infection itself play on the human brain, and the way in which this is happening because of the brain and body's immune system being one system, will begin to shift this conversation. And when that happens, as it is slowly happening, when we begin to pick up the pieces of our lives, I believe that it will also force the question, how do we begin to address the brain as an immune organ? And it will lead to the exploration, a deeper exploration of many of these tools that we now think of as integrative or outside of the classic medication and CBT, right? Like, I think it's going to help break open the door that clearly I'm trying to break open in our national dialogue through the work that I do. That's my hope, that is the silver lining here.
That's great. Thank you. We have a few minutes left in our live stream here. and our interview with Donna Jackson Nakazawa. I wonder if there are any people who are participating in the Zoom session that have questions that they would like to ask. You can put them in the chat, and then I can call on you and you can ask them in person, or however. If you're listening on YouTube, unfortunately we have the comments off by default, and YouTube has some idiosyncrasy where they don't provide all of the spotlights. The spotlight is only on the person who's actually speaking, and so you actually need to be in the Zoom call to see the ALS interpreter. But I wonder if there are any questions for Donna before we call it a day. Hogan.
Donna, that was so beautiful to hear. I thought I would have to get off before I could just thank you for talking with us. And I'm going to look into how I get to hear your 3-part series. I didn't know about that. One of the things that I hear when I hear you talking is, how the field is just exploding around this, and we need the research, and we have to be careful about our assumptions. And at the same time, I'm aware that so many things are relatively safe to try if people carefully. And I put in the chat that my brother's a gastroenterologist, and he discovered that the combination of an H1 and an H2 blocker interrupt the inflammatory cascade in COVID. He was researching GI. And so now down in Jackson, Mississippi, those guys are all taking it. If they get COVID, they're taking Pepsid and cetirizine because it's safe. And the conclusion was it's so safe, and we don't have time to research this. And I gave it to one of my patients that has brain fog and autoimmune issues, and it helped. And he had told me he had seen it help. So, it just feels like there's this balance we have to have, and being willing to say, these are relatively safe things. We need to go ahead and try them. And sometimes that's the way we make it to the new knowledge, not the research. The research might back it up later and might say, hey, adjust how you're doing it later. And it's just so hard to get the medical community to come around to something as broadly effective as neurofeedback, as you know.
Psychiatry has tools that they like to use based on the brain as a chemical organ, not as a structural organ, and most definitely not as an immune organ.
No, I'm a psychiatrist, and I run into this.
Right.
Banging my head against
the role, and you make me so happy because but that's usually who I hear about if there's going to be a grumbly, post or blog somewhere. It's going to be a psychiatrist, and yet, 5-10 years later, they will definitely start to understand, we've got to actually start thinking about these aspects of how we treat patients. But it's still the few and the far between. I think things are shifting, and I think that psychiatry is more willing to say, all right, well, try X, Y, or Z. But of course, the fear is always we don't want to make a patient worse. And so that's why we need more epidemiology, and we need more research to be able to show the broader field this actually does no harm.
Well, and actually to show, they need education so they know how to consume or to refer safely, how to evaluate whether their patients are safe with that neurofeedback provider.
Absolutely. And I'm not an expert in that, but I absolutely agree. It's sort of, so much of it is about the provider, but, we're still in psychiatry, we're still trying to get psychiatry to accept a basic thing like exercise and diet matter to the immune system. Like that, people can be in a psychiatric practice getting medication for 10 years and nobody has ever mentioned to them the word inflammation, the word exercise. And so we're starting there, neurofeedback is way down the list of crazy ideas like changing your diet. So many psychiatrists are coming around, and again, this sounds like I'm bashing psychiatry, and that
No,
is
you don't.
not
You're not.
what to do, because I believe in medication. I believe in psychiatric medications. I've seen them change lives, especially when they're utilized as a tool with other tools in combination. And you can't take away the experience that I've had witnessing medication change people's lives that I love. So I know that that's true, but I also know it doesn't really work if you don't combine it with a lot of other changes. And if you don't, the efficacy actually is fairly spotty.
This is something that comes up I know that, for example, Bessel van der Kolk talks a lot about embodiment and that as a means to address, for example, trauma. I wonder if you might talk a little bit about some of the other things like diet and movement, yoga, and some of those kinds of things. Is that some of is there research on the use of these?
I don't know how much time we have, because I don't have on the right glasses, to be honest.
We have a couple of minutes.
Yeah, so I'll definitely address that in 3-part series. So obviously, the research on somatic experiencing and embodiment and yoga. I wrote a whole book about yoga and breath work and meditation, shifting the genes in our body and shifting us in an epigenetic way to downshift that stress threat response and how that creates changes in levels of inflammation. So we know that all of that really matters. With diet, we have a really exciting kind of new thing that we're coming to understand, the way in which safe intermittent fasting, which is not for everyone, can begin to send even immune cells in the body, but even microglia in the brain. Walter Longo out at USC and here Mark Mattson at Hopkins, not far from me, have been looking at how intermittent fasting tells your immune cells to get rid of the bad guys and can actually begin to get rid of unhealthy immune cells and unhealthy microglia in the brain, because the body, again, is starting to go into this heightened state and prepare. But in this case, it sends the message to do it in a way that helps the inflammatory response. So it's just such an exciting time to see how these things can come together. And what I predict, looking ahead to 10 years, is that as we begin to be able to look at this brain-body connection and understand the biophysical link, the cellular link between brain health and physical health, and see them as one thing, we will also begin to get a much better idea of each individual's state. So we will have the ability to look at microglia and whether they're overreacting. At Broad Institute in Cambridge, MIT and Harvard, they're looking at when microglia change from good guys to bad guys, so they can actually create like a barcode sequence on that and know when that's happening in an individual. And my dream is that when a kid is going in, they're 9 or 10, when we now give them their first cholesterol test, right? Sometimes even earlier, they're also getting this basic immune function test, and they're getting brain scans. And we'll have the tools and we'll be able to read through different biomarkers and signals that state of brain health in a way that will say, let's begin to try these 15 things. Let's try neurofeedback, and let's also try exercise and diet and blah, blah, blah. And we'll see what works in that individual. We'll be able to do that at the other end of the lifespan, and we're already starting to do it in Alzheimer's and dementia. And we'll say, we've got 40 things we can try, and then we can continue to look at brain scans, and we can look at microglial activation, and we can look at inflammation, and we'll know what's working and what's not working, and we'll be able to prevent a whole hell of a lot of suffering.
That's so great. Thank you so much for taking the time to talk to us today, Donna. If anyone who is attending today is interested in the series that's coming up, it starts next Tuesday, same time, 1 o'clock Eastern. You can find out more by going to the 𝗜희𝘁𝗄𝗏.com website. You can also write to me at info@𝗜희𝘁𝗄𝗏.com. I put the email in the chat. So thanks to everyone. Thanks to 𝗬𝐶𝑖, our wonderful interpreter. And Donna, do you have any last things to say at all? Yeah.
Well, I just want to shout out to all of the providers here, because these are really difficult times, and a lot of people in my very close network are providers, healthcare providers, doctors, therapists, etc. It's really tough. And you guys you're going through an added layer of stress. And I'll talk a little bit about this in the seminar, but we know statistically that many people come to these professions because they've suffered their own wounds. And you all know the term, the wounded healer, the idea that you come to this work because you have your own trauma and you're helping others feel safe and seen and known and healed in a way that, some part of you may have wished that you were safe and seen and known and healed at some point in your life. And this is a tremendous way to help resolve trauma by helping others. But we also know that wounded healers often take the least good care of themselves. And so just a shout out to all of you, and just as from one human heart to another, thank you for the saving that you're doing. But remember also to take care of who you are, and that we are the drivers, right? Micro changes we make in our own life, in moment to moment lived experience, they matter. They matter in terms of all that I've talked about, the messages that the brain is sending you in your body as to whether you're safe or not safe. Micro changes matter. And it's really hard right now to double down on self-compassion and self-care. Self-care is now such an overused word. But wounded healers, please, know how valued you are for the work that you do in shifting this universe at this time, but also know that we're the drivers, and the micro changes you make towards your own self-compassionate mindset and moments of being and self-care, they really, really matter, because we need you all.
Thank you. Thanks everyone for joining us today. We will hopefully see you next Tuesday.
Thank you so much for having me. I really enjoyed it. Thank you, 𝗬𝐶𝑖.
Thank you very much.
Thank you, Di. Hope you are well.
Thank you.
Thanks, everyone. Thanks, Lars. It was fun to have you, 𝗬𝐶𝑖. Thank you so much, Donna. I'm reading your book, so I can't wait for the series.
Oh, great. Wonderful. Thank you. And I would read all these chats. I'll go through them now, but I have to. Oh, that's so nice. You're all so welcome. Oh, thank you to the person who appreciates my metaphors and imagery. All right. Thank you guys. Thank you so much. Thank you for having me. Great pleasure. I hope to see all of you return next week.